Good afternoon. I'm going to talk about IoT and manufacturing. I'm Ali Shakouri from Birck Nanotechnology Center at Discovery Park and electrical and computer engineering. So there are different ways, in Silicon Valley introducing Moore's law, I thought, I should do it a little different. This curve is from Ray Kurzweil from Singularity that describes number of instructions per second per $1,000 since 1900, at how much it has increased by 15 order of magnitude. And of course, as a simple engineer, they have mouse brain and human brain there. I don't know how they divide it by $1,000, but that's beyond simple engineers. What really enabled this revolution is the silicon platform. And this type of devices are behind the communication and the computing revolution. One of the questions that I'm going to discuss is that, is this enough for the IoT that we are talking about in the future? And, I guess I don't want to dwell on it too much. The potential impact in trillions of dollars, how many connected devices, predictive data analytics. But as you heard in the first talk, sensors play a role. You can only deal with data about something that you measure. We want to move in the era of digital pharmacy, digital health, smart infrastructure. And we have nice devices in the lab scale. But for anything that is not silicon-based, we don't have a path to commercialization. That's what this Death Valley shows. So what we really need is a platform to introduce new type of sensors. Why is it we need non-silicon sensors? The cheapest silicon sensors we could get are RFIDs, are a few cents. They really don't sense anything. It's just an identification number. If you want to sense things based on silicon, typically you need 50 cents to $1 sensors. And for a lot of the commodity, adding sensors, distributed sensors at that cost is prohibitive. So what could be the platform? What could be the building block of the future sensors? What we call a smart film. Smart is a function of the film, but what we think is the importance is the scalable manufacturing of aware and responsive thin films. If we have these devices that include batteries, possibly remote powering, RFID wireless communication, some active biologicals or pharmaceuticals, sensor and actuators. These are building blocks of that can provide a lot of data analytics for us. But we need to integrate microsystem, nanomaterials, soft materials, and flexible substrates. Very quickly, this is an area we have been working in the last couple of years. Birck Nanotechnology Center is about 11-year-old. And the Birck Center was developed as a standard silicon microfabrication. Something that we have done is to develop these roll-to-roll facilities. These are the type of equipment that are used in a lot of cases, for example, for organic light emitting large area displays. What we are trying to use that is for sensor applications. College of Engineering went through a big expansion, about 108 new faculty in the last 5 years. One of the preeminent teams that were selected in this area of nanomanufacturing for IoT. And one of the things we realized early on that we cannot do this on our own. We really need to bring industry. So we have a consortium. And what is unique about this IoT is really bring different minds together. Where can you hear to have somebody from Lilly in a pharmaceutical company sit down with Applied Materials, with United Technologies, and some sensor companies like Landauer? Because I think this is the kind of conversation we need if we want to introduce novel IoT devices in the market. Just an example of what type of tools are needed. This is something that we are going to install over the summer. Is a 45-feet-long smart film processing unit, and can basically enable sensors in ag, in food, in environmental, that now complements what is available today with silicon. So this is an area that we have expertise. Another area you may not be aware is that Purdue is home to Hewlett-Packard Printing Center. You know, it's interesting. You would think printing, especially the laser jet and inkjet, is well established, something that you have in your offices. It turns out there is a lot of printing quality control, microstructure analysis that can happen. And basically, the technology developed at Purdue is in hundreds of millions of these units that are sold all over the world. This is an example of a HP web press that prints at 800 feet per minute. Duplex 40-inch wide paper. Every page can be different. That's what is called digital printing. What we want to do is to use this type of technology to now make smart sensors, and that's what can bring the cost of the sensors significantly below what is available today. What are some of the examples of the new type of sensors? This is a project that started a couple of years ago by Professor Ziai. It's called Smart Wound Dressing. For chronic wounds, two factors control the healing. One is the moisture, and often that is controlled using the dressing that you put there. But the second factor is oxygen. And for chronic wounds, they have to put the part of the body under the oxygen tent, and you would think how invasive it is. Here is a paper-based device. Parchment paper, it turns out, is a good smart device. And on that, you have a series of sensors and actuators, and these are already demonstrated. So what you can do on a paper-based device is you can sense oxygen, you can sense pH, you can actually generate oxygen locally in the areas that are needed. So this is the kind of technology that you can never do with silicon. And this is what the kind of technology can change healthcare. Then the patient does not have to go that often to the hospitals, and the doctors could monitor a lot of these remotely. Another example maybe is not as fancy title, is a smart diaper. What a smart diaper in this case could do is to measure nitrate, which is related to urinary tract infection. And the whole idea is to have a sensor that has batteries, some communications, and some sensing to measure this nitrate and send the signal to the nurse. And what you need to have for this is something that only works for a couple of hours. If it's cheap enough that, like the diaper itself is disposable, then you can enable a level of smart function that you could not do it using other techniques. Beyond these examples, some of the futuristic area, what is called patient-centered precision medicine. So today, you know, pharmaceutical industry is high tech. They spend billions of dollars to develop new drugs. But how we take it is not that different from 100 years ago, how our grandparents took it. You know, take a pill before the food. You know, how many of us forget to get the right pill at the right time, especially for the elderly? People are talking about do the genotyping, phenotyping, and have a specialized drug for each person. The biology part of it is complex, but even the simplest part, can we have a personal pill that you just take one in the morning, and whatever is needed at the time is needed is released. And then later on, you can add some sensing. If you have fever, maybe something could change. And all the data goes to your cell phone. You don't need millions of transistors. You don't need huge type of computing that we have today in our phones. You need some simple functions, but need to be so cheap and fully integrated with biological. And this is the kind of thing we think we can do with these smart films. Another area which it's called smarter agriculture. You know, nobody wants to make dumb things anymore. Everything should be smart. What is the idea is if you could measure soil nutrients, moisture, pH, microbiome, disease, all the way to storage, packaging, and supply chain, we could improve the agriculture quite a bit. But as we have been discussing with our colleagues in College of Ag, Karen Plott, this idea of precision ag and variable rate technology has been around for 20 years. It's not something that is widely used or very rarely used. This is quite different from what you have in your phone. Think about what you were doing 20 years ago. and what we are doing today with your phones. Why is it that this technology has not come in? If you talk, really the problem is sensors are too expensive, and you have to live in a harsh environment. Your phone, you have it always with you. You don't put it outside under the snow, under the rain. I don't know how many companies could guarantee the phone if you keep it there. Imagine you want to do that environmental monitoring, but cheaply. And that's basically we cannot do with today's technology. One of the areas we are working with this disposable sensors is that sensors you put in the soil, they get the data for a week, 2 weeks, and after that they decompose. Maybe they are made of fertilizers so that you don't even, you help the soil condition. But again, the complexity of the information is not much, but we need certain level of control and sensing and actuation. Food safety and food waste are huge areas. I don't know how many of you know, 45% of fruits and vegetables are lost from what is produced. 20% meat lost. Average food produced in the world, 1/3 of it is lost. This is with the best state-of-the-art transportation system, refrigerated and so on. That's what we have. And the world population in the next 30 years will get to 9 billion people, and we don't have that much more land to feed these people. What could help quite a bit is why is it in 21st century you still go to a supermarket and there is a static expiration date for the food? How much good food we throw away because we need to be conservative, otherwise people get sick. But the reverse of it, the date is okay, people get sick, and now you have huge problems with the medical cost. What is needed is this type of sensing for pH, temperature, moisture, to have some active pricing for the food. And this is one of the examples, the kind of thing that could happen at places like Purdue. Lisa Maurer, who is the director of the food science safety program, working with material scientists, Leah Estancio, with this printing center I mentioned, Jan Alebak and George Chu, are working on devices that could measure E. coli, salmonella. They're also looking at the food freshness. These are the kind of disposable devices. If you could make it cheap, it could help quite a bit in terms of reduction of the food waste and also detecting some of the bacteria. We think this area of IoT is quite exciting because you can bring industries and functions that have not collaborated before. There is a lot we can learn from each other: pharmacy, food packaging, agriculture, smart infrastructure, connected transportation, digital health, anywhere that you need a sensor. And sensors, what is interesting is there are a few things you need to measure, physical and chemical. And once you have the platform, you can actually impact quite a few of them. I wanted to have enough time for discussion. What we really think Purdue could do in this domain is to create a high-tech manufacturing ecosystem. Why this is important? Well, I guess first of all, how other places have done it. Research Triangle Institute was, at the time, North Carolina was among the poorest states. They were able to start a public-private partnership that led to the growth of biotech and information technology there. There is another example in Europe. IMEC is a microelectronics center in Belgium. And in the 1980s, the big players in Europe, Germany, France, and Italy, they all had big programs, big companies, Siemens, Thomson, and so on, in microelectronics. And Belgium was making good beer and chocolate. And they said, well, we need to do something in the high tech. So they started this center 30 years ago. And what is interesting is that 30 years later, they are ahead of Germany and France in the IC technology. The way they did it is a public-private partnership, pilot factory. People from different industries work together. They did not work with just one industry. So this is something we think we can do in Indiana because we need the manufacturing of these is what brings the cost down. And we haven't discussed as much. People all talk about everything should be connected to internet and so on. At the end, where do you want these devices to be made? Is today's model of everything made in China and Asia and then used here, do you think is sustainable in the next 30 years? what are we doing with the population that were used to be involved in the significant manufacturing here in the years to come? What we think is that if we have partnership with Silicon Valley in terms of enabling new applications, we can do the manufacturing in US, but we need new business models. I think that's one of the other ideas. Everybody was talking about the business model of how services are replacing the purchase price. But the question I have is, we need to, in the same business model, to consider how these barriers for manufacturing innovation could be solved. Here is a case as a chicken and egg. Today, any of the devices that I showed you, if somebody says, well, that's exciting, but for me to do a field trial, I need 100,000 of them, I cannot say, let's hire 1,000 students, each one of them make 100. That's not going to work. But that's exactly where we are. We don't have the pilot, but that's something that we can do locally, but also the job creation. I will be glad to answer if there are any questions. Yes. Yes, yes. So the only way this could work is a public-private partnership. So we are in discussions with IEDC, Indiana Economic Development Corporation. We just had a meeting with Indiana Secretary of Commerce, and the support is there. We are going to announce some of these initiatives early on. We already have an industry consortium we are working, but we need more participants. We need more applications, because the only way to bring the cost down is more of these industries work together. It's interesting, we forget how initial cost is hard. Everybody knows transistor changed the way we do things. And if you ask on the average, what was the big success story of a transistor? Maybe I should ask it here in the middle of Silicon Valley. What do you think was the first success story of transistors? Space program, traffic light, radio. Well, the one that I heard that was one of the first areas that really enabled a market that could not be done with vacuum tubes was hearing aids. And hearing aids, because you could not do it with the previous technology, you could charge more. Then the cost came down, then others came in. That's really the issue. And what we need for a lot of this food, ag, pharma is similar. We need a low-hanging fruit to start the manufacturing, and then the costs come down, and then other markets come in. So that's the reason we are really looking forward to see. What we want to have is a pilot facility. And for us, the success is more people use it. So if you have ideas for sensors that you think that could be have a market in the short term, we look forward to discuss how we could solve the manufacturing challenge. Any other questions? Yes. Yeah. Yeah, we look at, of course, challenges are always opportunities. And I think this is something that exactly we can solve. Part of the reason we are focusing on this is that we do have the manufacturing workforce. The life, the cost of living is so much cheaper there that you could do it. But in conventional industries, with all the international competition is very hard. We think we could innovate this area of new manufacturings where you need the workforce. Not everything is yet automated, but ideas come from Silicon Valley. So design in California. Exactly, but And the other part of it is the actual centers for agriculture, food, processing, and so on are in Midwest. So it's not that you separate the two. We can really benefit on both sides. Yes, but yes. So I guess that's what we tell to our state. If you don't do it, others will do it.
That's right.
Exactly. Okay, thank you very much.